In this second lecture, we will review the ways that we can display quantitative data. As with categorical data, we can use frequency, relative frequency, percent frequency, as well as a range of charts and graphs. To demonstrate a frequency distribution, let's use a business example we can relate to, an auto repair shop. We have data for 50 customer invoices for the cost of tune-ups. Here's the raw data. Again, it's difficult to quickly draw any conclusions from just looking at these 50 different data values. Because the data is quantitative, we need to define classes or groups for the data, which must be non-overlapping and of equal width. There are some guidelines for determining the width of the classes in these next few slides. The goal is to use enough classes to show the variation, but not so many that some contain only a few data. Making the classes the same width reduces the chance of inappropriate interpretation. Bottom line, determining the number and width of the classes is by trial and error and could be different for each data set. It is possible that the bottom and the top class could be open-ended. For example, for the auto repair shop data, if we choose 6 classes, we divide the total range by 6, we end up with approximately 10 for the class width. So converting this into a frequency distribution, we see the number of data points within each of those classes for the total of 50. As with categorical data, we can expand this to look at the relative frequency and the percent frequency. And again, you note that the relative frequencies add up to 1, the percent frequencies add up to 100%. And as we categorize or display any data, it's important that we try and draw conclusions or insights from the data. Here's some of the things which I would conclude from looking at that relative or percent frequency distribution. We can also take the same data and display it with a few types of charts. The first and simplest is a dot plot. Horizontal axis showing the range of data. As you can see from this dot plot how the data points are distributed from the minimum to the maximum across the entire range, with the repeats stacked up. A histogram is a much more useful graphical method of displaying the same data. As with the bar chart for categorical data, we need to divide the data into classes. And with this graph, we can more quickly see the distribution of the data across the classes and the total range. A histogram can show if the data is symmetric or skewed. Symmetric data will appear to be nearly mirror image to the left and to the right of the center. Left skewed data will have a longer tail to the left, and right skewed data has a longer tail to the right. For extremely skewed data, for example, for company salaries or housing costs, we can see a very long tail. In the text chapter 3, we'll understand how to deal with skewed data and the possibility of outliers. We can also develop a cumulative distribution from a frequency distribution. This is simply adding up the proportion of the values with less than or equal to each of the classes. In this case, we can create a new column of data on the same table where we add up and accumulate. So a cumulative frequency just continues to add up the numbers as you go down the chart. Relative frequency, the same thing. And a percent frequency, the same.